get a better understanding of coordination complexes, it is necessary to get acquainted with certain terms which are commonly used in coordination compounds. Some of the important terms that you should be knowing are labeled in this following complex. You can see here coordination sphere, central ion, ligands, coordination number, ionizable anion or counter ion, oxidation number, etc. These are some of the commonly used terms which we encounter in coordination compounds. Let us first learn about each one of them in detail, and still there are many more terms we'll be learning apart from what we have seen just now. Coordination entity, a chemical compound in which the central ion or atom is bound to a set of number of atoms, molecules or ions is called a coordination entity. Some examples of such coordination entities include COCl3 NH3 taken thrice, FeCN taken 6 times 4 minus. Now you see another example of coordination entity. So what do you see here? There is a central metal ion and then a molecule of ethane 1,2-diamine is bound to the central metal ion. 3 such molecules are bound. All together is enclosed in a square bracket, and this is called as a coordination entity. Central atoms are central ions. The atoms and ions to which a set number of atoms, molecules or ions are bound are referred to as central atoms or ions. In coordination compounds, the central metal atoms act as electron pair acceptors and therefore act as Lewis acids. Now you can see an example of a central atom or ion. In this coordination sphere that you see, cobalt atom is the central metal atom. Ligands. What are ligands? These are the atoms, molecules or ions that are bound to the coordination center or the central atom or ion. These ligands act as electron pair donors and therefore act as Lewis bases. These ligands can be either a simple ion or a molecule. For example, Cl minus, NH3, etc. are very small molecules, simple molecules or ions that can act as ligands. There are some molecules which are very large, also can act as ligands. For example, ethane 1,2-diamine is a large molecule which can act as a ligand. There are so many ligands, and some of the ligands are illustrated here. And the definition of ligands also is specified. You can see ligands are the species with lone pairs of electrons that form coordinate covalent bonds with a central metal ion. So what happens in a coordination sphere? The ligands donate a lone pair of electron towards the central metal atom and form a coordinate covalent bond. Here you can see water molecule containing a two lone pairs of electrons, and chloride ion containing lone pairs of electrons, ammonia molecule, CO molecule, Cn minus, all contain lone pairs of electrons in them, and therefore they can act as electron pair donors, so therefore they can act as ligands. Now let us see how ligands are classified. Ligands are classified based on the charge on the ligand and the central metal atom. Ligands are classified as follows. Anionic ligands. What are anionic ligands? As the name tells you, anionic ligands are negatively charged ligands. For example, Cn minus, Br minus, I minus, Cl minus, all these are anionic ligands. And what is a cationic ligand? As the name tells you, a cationic ligand is positively charged. An example is nitrosonium ion, NO plus ion. Then what are neutral ligands? These are the ligands which do not contain any charge. They do not possess any charge. They are neutral molecules. But still they contain lone pair of electrons which can be donated towards the central metal atom and can act as ligands. Here you can see a list of various ligands that you see in coordination compounds. So negative ions include Cn minus, NO2 minus, OH minus, NO3 minus, F minus, Cl minus, Br minus, O2 minus. Positive ions include nitrosonium ion, NO plus ion, or hydrogenium ion, N2H5 minus. Neutral molecules include CO, NH3, ammonia molecule, H2O, water molecule, NH2OH, hydroxylamine, CH3NH2, methylamine. And now let us learn what is denticity. It is the number of donor groups in a single ligand that bind to a central atom in a coordination complex. Did you understand what is? Based on denticity, ligands are classified as follows: unidentate ligands, bidentate ligands, polydentate ligands, ambidentate ligands, and chelate ligands. Now let us learn about what are mono or unidentate ligands. What does mono or uni mean? It means one. If the ligand contains only one atom that can bind to the coordination center, then such a ligand is called as unidentate ligand. For example, ammonia or Cl minus, H2O, etc. They bind to the central metal atom or ion through only one single bond, and that is why they are called as monodentate or unidentate ligands. Here you have a list of various monodentate ligands: fluoro, chloro, bromo, iodo, cyano, hydroxo. All these are monodentate ligands and carry a negative charge. H2O, ammonia, carbonyl, these groups contain no charge on them. So they are neutral ligands and unidentate ligands. Nitrosonium ion, ammonium, and hydrogenium ion are unidentate ligands which have positive charge. For a better understanding, you can see here what is a monodentate ligand. In this picture you can see a monodentate ligand donates one lone pair of electron towards the central metal atom and forms one single coordinate covalent bond. And just below that you can see a bidentate ligand also. Now we are going to learn about bidentate ligand. Just before that, you see this picture that will develop a better understanding of what is a bidentate ligand. So you can see in this picture there is a molecule which contains two donor atoms, and these two donor atoms are donating two lone pairs of electrons towards the central metal atom. As a result, two coordinate covalent bonds are formed between the ligand and the central metal ion. So such ligands are called as bidentate ligands. So what are bidentate ligands? Ligands which have the ability to bind to the central atom through two separate donor atoms like ethane 1,2-diamine, oxalate ion, etc. are called as bidentate ligands. Now you see these two ligands, ethane 1,2-diamine and oxalate ion. In these cases, you can see, in case of ethane 1,2-diamine, there are two NH2 groups which carry a lone pair of electrons, and these can donate an electron pair towards the central metal atom. And now you see, in case of oxalate ion, the two oxygen atoms contain two lone pairs of electrons and can donate one lone pair of electron each towards the central metal atom, thereby forming two coordinate covalent bonds. There are many more bidentate ligands, and some of these include trimethylene diamine and acetyl acetanoto. Now let us see what are polydentate ligands. Some ligands have donor atoms that can bind to the coordination center through many donor atoms. Such ligands are called as polydentate ligands. EDTA4- ion is a polydentate ligand. What is EDTA? Ethylene diamine tetraacetate ion. You can see here, EDTA molecule or ion contains 4 oxygen atoms and 2 nitrogen atoms, which contain a lone pair of electron on them, and they can act as donors for forming a coordinate covalent bond with the central metal ion. Therefore, EDTA molecule can bind itself to the central metal ion through 4 oxygen atoms and also 2 nitrogen atoms. Hence, it is a hexadentate ligand. You can see an example of a complex formed by EDTA with cobalt atom. What are chelate ligands? When a polydentate ligand attaches itself to the same central metal atom through 2 or more donor atoms, it is known as chelate ligand. The number of atoms that ligate to the central metal atom are termed as denticity of such ligands. For example, ethane 1,2-diamine is a chelate ligand. It can ligate itself to the central metal atom through 2 nitrogen atoms that are present in the molecule. They contain a lone pair of electron in each atom, and they can form a ring-like structure along with the central metal atom. And in case of a polydentate ligand like EDTA, you can see in this complex, EDTA in this complex forms a ring around the central metal ion. Such complexes are called as chelate complexes, and such ligands are called as chelating agents. All bidentate and polydentate ligands can act as chelating agents or chelating ligands. You can see here how ethane 1,2-diamine forms a ring around the central atom. So you can see here a copper complex with with ethane 1,2-diamine. It is a chelate complex. If a chelating ligand is present in a complex, the complex is more stable, and more the number of chelate ligands, more is the stability of the complex. The stabilization of coordination compound due to chelation is known as chelate effect. What are ambidentate ligands? Some ligands have the ability to bind to the central metal atom through two different atoms present in the same ligand. For example, SCN- ion can bind to a central metal atom either through nitrogen atom or through a sulfur atom. Such ligands are known as ambidentate ligands. Here you can see a list of ligands that can act as ambidentate ligands. NO2- ion can ligate through two different donor atoms. For example, if nitrogen is the donor atom that donates an electron pair towards the central metal atom, then it is called as nitro. And the same ligand, if it is donating an electron pair towards the central metal ion through oxygen atom, it is named as nitrito. Another example of ambidentate ligands is cyanide, Cn- ion. If it ligates with the central metal ion through carbon, it is called as cyano. And if it ligates through nitrogen atom, it is called as isocyano. Now you can see the next compound, the next ligand, thiocyanato ion, SCN- ion. This can ligate with the central metal atom through a sulfur atom or through a nitrogen atom. If it ligates through sulfur atom, it is called as thiocyanato ion, and if it ligates through nitrogen, it is called as isothiocyanato ion. Now we have a very large list of various ligands that can act as mono, bidentate and polydentate ligands. You can see in this list aqua, ammonia, fluoride ion, chloride ion, cyanide ion, thiocyanate ion, hydroxide ion, nitrite ion. All these can act as monodentate ligands. And coming to bidentate ligands, you can see ethane 1,2-diamine, bipyridine, orthophenanthrolene, oxalate ion, carbonate ion acting as bidentate ligands. And the polydentate ions include diethylene triamine triphosphate ion, ethylene diamine tetraacetate ion. These are some of the ligands which are commonly seen in case of coordination complexes. The coordination number of a central metal atom in a coordination compound refers to the total number of bonds through which the ligands are bound to the coordination center. For example, consider this complex of nickel. In NiNH4 taken 4 times 2 plus, the coordination number is equal to 4. How to calculate the coordination number of a metal ion in a complex? In case of monodentate ligands, coordination number is equal to the number of ligands that are present in the complex. In case of polydentate ligands, coordination number is equal to number of ligands multiplied by its density. Now let us learn what is coordination sphere. The non-ionizable part of a complex compound which consists of a central transition metal ion surrounded by neighboring atoms or groups enclosed in a square bracket is called as coordination sphere. In coordination center, the ligands attached to the coordination center and the net charge of the chemical compound as a whole form the coordination sphere. when written together. This coordination sphere is usually accompanied by a counter ion, that is, the non-ionizable groups that attach to the charged coordination complexes. For example, CONH3 Cl3 is a coordination complex. In this complex, CONH3 taken 3 times 3 plus is the coordination sphere and Cl minus is the counter ion. For a better understanding, you can look at this picture. See this complex of copper. It is Cu NH4 taken NH3 taken 4 times SO4. I repeat, it is Cu NH3 taken 4 times SO4. This is a complex compound. In this, what is the coordination sphere? Cu NH3 taken 4 times 2 plus is the coordination sphere, and the sulfate ion which is present outside the square brackets is the ionization sphere, which is also known as counter ion.